Okay, so today we're going to be talking about the remainder theorem and the factor theorem. And I think the big thing is, pardon me, I got quite a cold. The big thing would be to talk about what that actually means, and what do you actually need to know about that. I think the big thing would be, pardon me, that we're going to do synthetic substitution. I think that would be the first thing. Okay. Synthetic substitution means, when you substitute something in, you plug something in, right? And so normally if I say, hey, find f of -3 into this function, you put x, is -3 into that function and you see what you get as an answer. So if x is -3, you find the output or the y for what that is. Well, the truth is that there's a way to use synthetic division to do that. It's kind of cute. So if you plug in x is -3, okay, so they give you f of -3. That means if x is -3, okay, what you do then is you do synthetic division by saying if x is -3 here, then you need to say what answer would you get as a result, okay? And so you put synthetic division, the coefficients down, so you plug in -2, you got a 0 because there's a placeholder. You're going to have a 3. You're going to have a -15. And then you're going to have a 9. It doesn't look like a -15. I'll see if I can erase her. Let's see if I can fix her a little bit. Okay. Okay, so -15. I've got a new stylus here, so I'm trying to work it out. So the thing is, we could just plug it in and see what we get using our calculator. But synthetic substitution, you put the x in the box right here, okay? Because normally you've got like a factor and they're like, oh, divide, this polynomial by the factor x -2. And so you set that equal to 0, okay? And then you solve it for what x is equal to 2 then. Okay, so if you solve that, and so normally 2 would go in the box, you would do that math. So when we did synthetic division, say that we're dividing x -2 into a polynomial, the value you put in the corner coincides with the zero product property, right? You have to solve for what x is to make that happen. So you put that value for x right here in the box, and then your remainder would be, as follows. Well, when we're doing synthetic substitution, we already know the value of x. They didn't give us a factor. They give us the exact value for x. So we take this up here and we put it right here in the little box as -3. And then whatever we get as an answer will be the output if we plugged in -3 to that function. It's kind of weird. You can do it both ways. And if you do it right, you'll get the same answer both ways. If you do it wrong, well, then, it's up to you which one's right. And so let's do this here. So with synthetic division or substitution, you put the x value in the box, okay? And then we're going to divide it to say, okay, what would be the output? So we're going to get a 6 here, and we add these together, and you get -18, and you get a -15, and you get 45. So that means this is a 30. And then you're going to multiply this together, you get -90, and that means -81. So that means if you did this function, okay, by plugging in x as -3, your output would be -89. Okay, and so you can write it like that, or you can write it as an ordered pair. Okay, but normally people write it like this. Okay, so if you plug in x as -3, and if you just plugged it in the right side of your calculator, using parentheses for the x, you'd get the same answer. I just want you to practice saying, hey, guess what? There's an input-output feature if we do synthetic substitution or division, and it is helpful because, in truth, you may not need to use a calc, because when we do this, all we're doing is multiplying and adding and subtracting the basic stuff. You don't actually have to raise things to powers, where if you were trying to actually plug it into this function here, you probably would need a calc, okay, because there's a lot of powers going on and stuff like that. So it kind of is weird how the math works on both those things. So let's try doing f of 2. Okay, so the same function plugging into, again, we know x is 2, so we're going to put the number for x in the box, and then we're going to write down the coefficients. Remember phantom terms. First hour today, I did forget a phantom term for x to the third. Do you see how we're missing one? Well, I forgot that. So we get a -2. You have a 0. We have a 3. We have a -15. And then we have a 9. Okay, so let's do synthetic division or synthetic substitution. The method's the same. It's just, what are you going to do with the answer? You know, with synthetic substitution, you just look at the remainder to see, given that input for x, what do you get as an answer? So bring down the -2, you get a -4, you get a -4, you get a -8, -5, make sure I'm on the right track, yep. And then -10, this will give us a -25. I should zoom in because this is kind of ridiculous. Never mind. Okay, and then we're going to get a, -50. So it turns out that our remainder is -41. So that means that f of 2 gives us -41. Okay, or you could write 2 comma -41. But basically, if I had plugged in 2 into this function right here, I would have gotten as an answer of -41. Okay, which is kind of interesting. So synthetic substitution is plug in a value for x to a function. The remainder would be the output. Now, the way we're going to use it in this chapter primarily is to help us factor hard questions. What do you mean, woman? Well, we've learned how to do GCF. We've learned how to factor trinomials. We've learned how to factor cubics in this chapter. And we did some big kid factoring. And so what we want to do now then is to say, when I give you a hard problem that you can't factor it normally, can I use synthetic division to help me factor it in a better way? And the answer is, of course. Now, go with me a second. Do you see this polynomial has 4 terms? Well, ordinarily, you would approach this by splitting it in half and making a sandwich out of it and being like, okay, let's take out a GCF of the first half. You're left with 2x plus 15. The second half, you take out a -1, and you're left with 11x plus 24. Wait a minute. Do you see how the groups don't match up? That means if I ask you to factor it, it won't factor by grouping. We're going to have to find a new way to factor it. Okay, so sometimes there's multiple ways to factor the same question. The question is, how do I even do this? Okay, and so the answer is sometimes you've got to resort to synthetic division. Okay, and that will help us to factor things. Okay, and so let's think about how we would do this. Okay, so it's in this first question, it says, given that the factor is this, can you help us factor the rest of this problem? Okay, and so the question is, if I give you this factor, we need to know what x would be. So remember, if you've got a factor, of x plus 8, you can set it equal to 0 to say what x would be. So that would be -8 from both sides, so x is equal to -8. Okay, so the number you put in the box is -8. Okay, so if x plus 8 is the factor, -8 is the number you put in the box. And so then we got to write down these functions here. So we get the coefficients, the 15, the -11, and the -24. Now, I could teach you some other ways to factor things, but synthetic division is really a great way to factor hard things because synthetic division isn't that hard. Okay, it's a good catch-all to say, how do you factor hard problems? Let's use synthetic division to help us do that. So if I know x plus 8 is a factor, then that means the value for -8 is going to be the value for x, because normally we factor in order to solve equations, right? So then once we factor it, we set that factor equal to 0 to figure out what x would be. So there's a connection, and I'm trying to teach you not just how to do things, but also the vocabulary connection, the connection that you'll see here. So let's bring down this 2. -8 times 2 is -18. No, that would be -16, pardon me. And then you get a -1, and then you get an 8, and a -3, and then 24. Hey, our remainder is 0. So the deal is this. That means that -8 really is a 0 of this function, or a solution if it was an equation, okay? So -8 giving us 0 as a remainder is a good sign. Okay, that means one of the points on this graph is -8, 0. Remember, when we graph things, we're looking for where does it cross the x-axis. Those are solutions to these polynomials. So where it crosses the x-axis is a 0. So -8, 0 is a valid option. So them giving us that factor is really a helpful thing. And so -8, 0 is one of the solutions to this problem. Okay, if it were an equation. Okay, so we're trying to link those thoughts together. Okay, so it says completely factor this. Okay, so the factor they gave us was x plus 8. When we put the letters back in here, the remainder has to be 0, okay, if it is a factor, okay? And that's one of the questions from your last test is like, what do you know if Something divides unevenly. Well, that means that that binomial is a factor of the original polynomial. So let's put the letters back in. So you're going to get at 2x squared minus 1x and then minus 3. And then it says completely factor. So the factor they gave us was this, okay? And if we FOILed these back, we would get back to the original problem, okay? Again, factoring means break it up into parentheses, so multiply back to get to the original problem. Well, I bet you we can factor this trinomial as well. Okay, so it's going to be 2x and x probably. And then it's going to be probably 1 times 3. Yeah, that will work. If you rainbow it out, you're going to get negative 1x. So you get negative 3x and positive 2x is negative 1x, and then x plus 8. So the factored form should, when you FOIL it back out, okay, you'd put 2 of them together and get your trinomial, and then you'd take that trinomial times the last binomial, and you'd get back to your original problem. So your answer should multiply back together. And notice if we multiply these 3 parentheses together, you'd get an x times an x times, you'd end up with an x cubed. Yeah, that's what we started with, was a flavor of an x cubed. And we don't have to verify that it's true, but it should be true, okay? So if we want to factor hard things, synthetic division is our helper. Okay, so here we go. Let's move to the next side of our notes. Pardon me. Okay, look at this stinker. She's got 5 terms, okay? So do we know how to factor 5 terms? No, we do not, and that's okay, okay? So what we're going to do then is we're going to say, well, let's use synthetic division. Well, and how to use synthetic division? Well, they gave us a hint, okay? They said that one of the factors of this is going to be x minus 3. Okay, so if you're writing down your final answer, x minus 3 is one of the answers, okay? One of the parentheses, okay? And sometimes they'll say, go ahead and solve it, but it says, hey, just factor it, okay? So we know if x minus 3 is a factor, what would x have to be? Remember, set it equal to 0 and solve it? So if you do x minus 3 equals 0, you get x is equal to 3. Okay. So the number who goes in the box, okay, the 0 of this function, okay, if it's a function, but the value of x that's going to work in this function, this equation, it's not an equation, sorry. The value for x is going to be 3. Okay, I'll stop there. And so then we take 1, negative 10, 4, and 24. Okay, and what we're going to do then is we're going to do synthetic division. Okay, so we're going to bring down a 1, times it by 3, 2, 6, negative 4. Now, if you don't get a remainder of 0, you botch something, okay? And if you do get a remainder of 0, that means it indeed is a factor, okay? So if x minus 3 is a factor, then x equals 3 is going to be a 0, okay? And so it says, write it in completely factored form. Okay, so here's the deal. We've got x minus 3 as our first factor. And when we add these letters back in, we put the x back in, the x squared back in, the x cubed back in. So we've got x cubed plus 2x squared minus 4x, and then minus 8. And then we have to say, okay, I can factor that polynomial, okay, with 4 terms. Probably I can make a sandwich out of it. So slice it in half. Do the GCF of the first half, and if we take out a GCF of the first half, we're going to take out x squared. We're left with x plus 2, and we're going to take out a negative 4, and we're left with x plus 2, and then we get x plus 2 as our common factor, and x squared minus 4 as our GCF part. We have x plus 3, x minus 3, pardon me. Okay. Let's bring it up here, because do you see that that third polynomial or binomial is going to factor as the difference of 2 squares? Okay, and so one thing we talked about today in class was GCF is the primary thing you should look for with factoring. The second thing you should look for is difference of 2 squares, okay? And then after that, go ahead and look for, is it a trinomial? Let's do 2 parentheses, or let's do, if it's a binomial, you'll probably look for cubes. Okay, so primary is GCF. Second one would be look for difference of 2 squares. Okay, if it's not one of those 2, then you can look at it and say, is it cubes? Is it a trinomial? Should we make a sandwich out of it? Do factor by grouping? What do we do for these things? Okay, so you're going to get x minus 3. You're going to get x plus 2. And you're going to get x plus 2 and x minus 2, because remember that came from x squared minus 4. Okay, so there you go. So this is the factor form. Again, you should have, if you've multiplied that out, it should make this original problem. Okay. And you could do that, or you can just say, okay, can I tell that I'm going to multiply x by x by x by, yeah, that is x to the fourth. And you would get back to that problem at some point. Okay. So we're just kind of doing a slight visual. Now, if they give you 3x minus 1 is a factor of it, write it into factored form. Well, can you do synthetic division with 3x minus 1? No. Okay. If you're going to do synthetic division, you've got to actually have it just x plus a number, x minus a number. So instead of doing synthetic division, we're going to do long division here. And so we're going to take 3x minus 1 and divide it into 6x cubed plus x squared minus 31x and then plus 10. Okay, so if I do that, I'm going to say, okay, I'm going to have to multiply this by 2x squared, and I get 6x cubed, and then I multiply that, you get minus 2x squared. You've got to distribute a negative 1 to that row. So this becomes negative, that becomes positive. And so the first row goes away. You're going to get 3x squared and then bring down the minus 31x. Okay, and so then you have to times this by, it looks like, an x. And so if you multiply both these guys up front by just x, you get 3x squared and then minus x. Distribute a negative 1 to both of them. Changes both signs, you get negative 30x and then bring down the plus 10. And if you multiply this by negative 10 here, it will become negative 30x and then plus 10. Distribute a negative, it'll change both signs. And indeed, there's no remainder, which is exactly what, if it's going to be a factor, there can't be a remainder, can there? And so we're going to take 3x minus 1, and the factors of our original polynomial, which is here, would be 3x minus 1 times that quotient, okay? So it'd be 2x squared plus x, and then minus 10, and then we're going to factor this trinomial further. We're going to get 2x and x. Oh, I bet you it's going to be 5 and 2. Yeah, it's 2 times 5, because we're going to need a rainbow. Notice it'll be negative 4x and positive 5x, which makes positive 1x. So make sure the product of the first makes 2x squared. The product of the last makes negative 10. The product of your rainbow has to indeed make positive 1x in the middle. And then you get 3x minus 1. So your three factors, when FOILed out, should get back to the original polynomial. And notice we will have an x times x times x, which is x to the third. And that's exactly what we have here. So we're using division or synthetic division to help us factor things, because division, factors mean they multiply. And so the inverse of multiplication is division. So it's helping us factor things. Okay. Now we're going to get into some vocab. Here we go. The first one says, given the f of negative 3 equals 0. Okay, you're like, what are you even saying? Well, if you plugged in negative 3 to a function, okay, the function on the right, then the answer is 0. You're like, yes. Okay, well, okay, breathe. That means one of the points on this graph would be negative 3 comma 0. Okay, because f of x equals, that means this is the x and this is going to be the y. Okay, so f of x is equal to stuff. This is the x value. This is going to be the y. Okay, and so if you plug in this number on the left, what you get is going to be what's on the right. Okay, so if you plug in negative 3, you get 0 for this thing. So that's going to be one of the solutions, or the zeros, to that polynomial. Okay, so depending how it ends up being framed. So negative 3, 0 is going to be one of the zeros or solutions to this problem. Okay, so if you want to find the rest of them, well, we can. Okay, remember, one way we can do hard factoring is to use synthetic division. And the x coordinate, okay, of the 0 has to go in the little box here. So we put a negative 3 here. We have 1, 5, 3, and negative 9. Pardon me. And then we say, so if I plug in negative 3, I'm supposed to get 0 for the output. So we're going to use synthetic substitution or synthetic division to say, if x is negative 3, it's going to help me factor this. So negative 1 times 3 is negative 3, and that's a 2. It's a negative 6. That's a negative 3. That's a 9. Look at us. We got a 0. So indeed, if you plug in -3 to this polynomial, you do get 0 as a result, okay? And so that means that one of the zeros really indeed is -3, 0, like they told us. You're like, I told you so. Well, then we can put in the x's back in here. You're going to get x squared plus 2x minus 3. And if we can factor this or solve this, we're going to be able to find the other two zeros of this polynomial. Okay, so let's factor it up. Okay, and remember you solve quadratics in one of 5 ways, and if it'll factor, that will help you. Okay, and so if this is x, I think it's going to be positive 3 and negative 1. Yeah, there you go. The rainbow will be positive 2x. So if you solve this, set each factor equal to 0, you're going to get x equals 1, and this will be x equals negative 3. So we already knew that x equals negative 3 is a 0 of this polynomial, or one of the x-intercepts. Now notice we got a duplicate, didn't we? So we know it's going to cross at negative 3. We also know it's going to cross at positive 1. We also know that our original polynomial, if you put like y equals for it, okay, it's going to be cubic and it's positive. And remember, that's trumpets to the right, okay, going up like this. So you can put the end behavior right on this graph, okay? Now, where the x-intercepts are and how many of them each there are is signified and shown by how it crosses the x-axis, okay? If you walk around the hallway and you see people like making out, okay, you know there's something going on there, right? Well, if there's 2 answers at the same point, how it touches the x-axis is going to be touch the x-axis without crossing, okay? So if it touches the x-axis and it doesn't cross it, that at negative 3, that's because there is a duplicate root at x equals negative 3. Okay, so we have the duplicate roots at negative 3, so that when it touches at negative 3, instead of crossing and going up through the axis, it's going to bounce off the x-axis. But then when it crosses at the 1, it's going to dive right on through. So if there's not a duplicate root there, it just goes right through the axis at that point. Okay, so the duplicate roots are evidenced where it touches the x-axis without crossing. Okay, it bounces off the x-axis. So, all right, so that's what that graph will look like with the end behavior with the duplicate roots and when it touches at those real values. Okay, the last one is a little weird. Okay, so let's go with it. We have zeros at negative 2 and 4. There's a double 0 at 4. And you're like, okay. Okay, so we know it's going to touch at negative 2 and also at 4. Okay, so let's talk. I think the first thing would be, let's work backwards. If we know x equals negative 2, okay, do you know what parenthesis made it? Is your brain like okay with saying, how do I get back to that parenthesis? Well, think backwards. If you got negative 2, okay, you would have solved an equation x plus 2 equals 0 to get there, okay? And so you would do x plus 2 as that root, okay? Let me pause this. Okay, so the thing is that also if your 0 is at x equals 4, of course it's going to touch at 4, but the factor who made it would be x subtract 4. Again, try it. Set x minus 4 equals 0, solve it, you get x equals 4. And that has a double 0, so that means it happens twice. So that if you write a function that does this, you could FOIL it out and get your answer. You can also write it as 3 parentheses and be like, okay, here we go. So that would be x to the 3rd if you FOILed it out. And so then you would get x to the 3rd, and it'd be positive, you know, when you FOILed that out. And so a cubic one that is positive is going to go up on both sides. And then we also are going to have it touch at positive 4 instead of crossing. And then it's going to cross at negative 2. So that will be what our graph will look like. So we can FOIL this. I'll do it real quickly and see what happens. You get x squared minus 8x and then plus 16. And then we also have to multiply by x plus 2. It's going to be x to the 3rd minus 8x squared and then plus 16x. And then 2x squared, and then minus 8x. Nope, minus 16x, sorry. And then it's going to be plus 32. So your answer, if you FOIL it out, would be y is equal to x cubed minus, I believe, 6x squared, and then plus 32. That should be the polynomial. So you can fill it out, but if it doesn't say you have to, then you don't need to. All right. Well, thank you so much. Have a good day.